The aim of this week's investigation was to construct a microphone and through doing this, demonstrate its operation using an oscilloscope. To do this, a long plastic tube, cling wrap, thin coated wire, an oscilloscope, and two magnets were provided. To build a microphone and be able to project its behavior on the oscilloscope, we expected that we needed to set up a circuit with a coil of the thin wire and allow the magnets to move within or near the coil to induce a current generated by sound. The behavior of this induced current can then be visually represented on the oscilloscope, demonstrating the operation of a microphone. In order to create the microphone as shown here, a piece of cling wrap was first stretched firmly over the top of one end of the plastic tube so that it was completely covered, and taped down to avoid it from moving out of place or losing tension. A long piece of thin wire was then cut and coiled around the tube at the end with which the cling wrap was taped to. One magnet was then put inside the tube so that it was resting on the cling wrap on the inside, and the other magnet was attracted to the magnet on the inside of the tube as shown. The ends of the coiled piece of wire were then stripped back to allow for its electrical contact, and the circuit with the oscilloscope was set up as shown. The end of the tube at which there is no cling wrap would be used at the point at which sound is projected, making the tube the diaphragm. This setup should then theoretically display the operation for a microphone on the oscilloscope, as the sound coming into the tube would force the magnets to move or vibrate with the cling wrap, causing the magnetic fields down the coil of wire to change. This change in magnetic fields causes a charge to move around the circuit, which allows the oscilloscope to measure the change in voltage. Overall, a signal is being picked up due to the current being induced in the coil. However, this proved fairly difficult in actually achieving a result. After setting up the microphone as explained, and after various attempts of projecting sound into the tube using our voices, sound apps, and even music, no results were actually being achieved. We gathered the cause may be due to the length of the coil, so set up another microphone as shown here, but with the complete roll of coiled wire, yet no results were still achieved. We decided to return to our original microphone setup and determine other possible setup errors preventing us from achieving results on the oscilloscope. We thought that the oscilloscope settings with reference to the voltage and time measurements may not be appropriate, so we attempted to adjust these, still no results were achieved. We then attempted to improve the electrical connectivity by stripping off more of the wire on the ends of the coil which are attached to the oscilloscope. After doing this, it seemed as if the oscilloscope was reading a signal. Johnny then came over and hummed into the tube with a deeper voice and low pitch which displayed a clear reading on the oscilloscope. This meant that a signal could only be picked up at a low pitch, as Johnny was able to reach the resonant frequency of the tube. The reading from Johnny's voice can be seen here, in which the signal received was a sine wave. Observing the amount of voltage and time over 5 periods, then dividing by 5 to improve the certainty of the reading of the period, the frequency can be calculated by calculating 1 over the period. The frequency obtained of Johnny's voice was approximately 200 Hz. The source of uncertainty in this experiment derives primarily from the oscilloscope device itself. Overall, to ensure the setup of the system of the microphone is efficient and productive, all wires must be electrically connected properly, and the resonant frequency of the tube must be achieved. To restate the operation of the microphone, as sound reaches the magnets, they are moved back and forth, causing the magnetic fields to change down the coil of wire, inducing a current in the coil. In this sense, sound energy is converted into electrical energy through the circuit. The resulting signal reading from the oscilloscope displays a sine wave.